Hello everybody. In this video, we will cover OSI layered model and following are the objectives which we will cover in this video. Introduction to OSI layered model, various layers in OSI model versus DoD4 model, OSI model versus TCP IP layered model, and how OSI layer model works. OSI layered model. Open System Interconnection, generally called as OSI model, is a model which defines a way that how network communication works. For example, it shows how a data transmits from one device to another and so on. OSI model is a layered model and it consists of 7 layers. Each layer is a set of protocols which defines how the data will transfer between these 7 layers. OSI layer also is the troubleshooting process in network communications up to issues of any level. OSI model, sometimes referred as OSI reference model, since it deals with the system open for communication to other systems without requiring changes to the underlying hardware and software. Let's discuss the different layers of OSI model. OSI layer model has 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Physical layer is the lower level layer and application layer is the higher level layer. Layer 7, that is application layer, layer 6, presentation layer, layer 5, session layer, layer 4, transport layer, layer 3, network layer, layer 2, data link layer, layer 1, physical layer. Each layer has different functions and different processing. In application layer, this layer provides front end to the user. Presentation layer, this layer takes care of translation, compression, and encryption. Session layer, this layer is useful for session control. Transport layer, this layer is responsible for reliable communication of messages. Network layer, this layer is responsible for sending and receiving the packets from device to device. Data link layer, this layer is responsible for transfer the data frames. Physical layer, this layer is responsible for transmitting bits through physical medium. Now let's have a look in detail of OSI layer and compare to DoD4 model. Application layer, which is the higher layer, stands at layer 7. Platform for users and application processes to access the network services. Applications, for example, end user layer, program that opens to view, receive, or send. Examples: resource sharing, remote file access, printer access, web page. Devices and protocols, user applications, protocols, SMTP, browser. Presentation layer, it formats the data to be presented to the application layer. Syntax layer means it is also called as the syntax layer. It encrypts and decrypts. Example: encryption, decryption, compression, translation, all perform in this layer. Protocols and devices, for example, JPEG format, ASCII format, EBCDIC format, TIFF format, GIF, etc. All these formats come under this layer. Means any processing related to the translation, encryption, and decryption happens in this layer. Session layer. It allows session establishment between processes running on different systems, like synchronization, session establishment, resync, terminate, and logging. Protocols, logical ports, RPC, HTTPS, MS SQL, NFS, FTP. Means it maintains the session with the other node. Resync the node session. Terminate the session, logging the session details, all happen in this layer. Transport layer. Transport layer ensures the message delivery, error-free sequence and with no duplication or losses. TCP layer. Host to host and flow control. It's a TCP layer which sees the host to host communication and flow control. Examples: message segmentation, message flow, message acknowledgement, message traffic control. Generally, it uses two types of protocols, TCP and UDP. TCP is the transmission control protocol and UDP is the user datagram protocol. TCP is the connection oriented, UDP is the user datagram protocol which is connectionless. Network. Network layer controls the network path and packet handling. Means it routes the packet to the destination. Packet filtering. This layer is used for the packet filtering. It contains the IP addresses. Example: routing, subnetting, logical, physical address mapping. Device and protocols used in this layer: routers, layer 3 switches, protocols IP, IPX, ICMP. Data link layer. It provides error-free transfer of data frames from one device to other. Frames. In this layer, it contains MAC address. It establishes and terminates logical link between nodes. Frame traffic control, sequencing, acknowledgement, frame error checking, media access control. Devices and protocols used in this layer: switch, bridge, and WAP. Protocols: point-to-point protocol and SLIP. Physical layer. Physical layer controls transmit and receive unstructured raw bit stream over the physical medium. Physical structure. Physical layer shows the physical structure, how the exactly devices will be connected to each other with the help of cables, hubs, etc. Encoding, decoding, physical medium transmissions, digital to analog and vice versa, are happen in this physical layer. Devices and protocol used in this layer are hub and etc. When we compare this model to DoD4 model, we can see that in the DoD4 model there are 4 layers: process layer, host to host layer, internet layer, network layer. Application layer, presentation layer, and session layer are combinedly called as the process layer in the DoD4 model. All the processing happening in application, presentation, and session layer are happen in the process layer. Host to host layer is called as the transport layer. Internet as compared to network layer. In OSI layer, it is called as network layer, and in DoD4 model, it is called as internet layer. Again, data link layer and physical layer are combined to create a network layer in the DoD4 model. So this was the processing. Let's look at OSI model and TCP IP model. Both the reference models are based on layered architecture. In OSI model, each layer is defined separately, whereas in TCP IP model, layers are combined to form a layer. Application layer, presentation layer, and session layer together forms application layer in TCP/IP model. Transport layer is same in both reference models. Network layer in TCP/IP model is called an internet layer. Data link layer and physical layer together form an network access layer. OSI reference model is generic model and TCP/IP model is protocol oriented model. OSI model has 7 layers whereas TCP/IP model has merged several layers together and have 4 layers. OSI model transport layer is connection oriented whereas TCP/IP is both connection oriented as well as connectionless. OSI model is developed by ISO whereas TCP/IP model developed by ARPANET. OSI model standardized router, switch, motherboard and other hardware device whereas TCP/IP helps to establish connection between different type of computers. So let's look at the layers of OSI model and TCP/IP model. In OSI model, we can see that application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer are working separately. But in the TCP/IP model, multiple layers are combined together to form a single layer. You can see that application layer in the TCP/IP model giving the functionality of 3 different layers in the OSI model. That is application layer, presentation layer and session layer. Means in the application layer in TCP/IP model, application services, encryption, decryption, translation, encoding, decoding and session establishment all are happening in the single layer. Transport layer is same in both the models and providing the similar functionality. Network layer is called as internet layer in TCP/IP model and giving the functionality of network layer. Again, we can see data link layer and physical layer are combined together to provide network access layer in TCP/IP model. Means network access layer in the TCP/IP model will provide the functions of data link layer and physical layer. Working of OSI model. So we'll see how OSI model works and example of OSI model working. Application layer prepares the data using application software. For example, we can create a document using a Word or any other document writer and save it. Presentation layer compresses and encrypts the data. We can encrypt the document with the password and compress the 10 MB document to 2 MB for saving the space. Session will be maintained with other node and that is taken care by session layer. So when we are sending this document to other person on a network, we'll attach the document to some service like mail service, or we can send it through file transfer protocol or by remote desktop protocol. So for sending this document, first of all we will create a session with the another node. Once a session is established, transport layer will be responsible for divide the data into segments and ensure the error-free and sequence delivery to other node. For example, when we are sending a large document, it cannot be possible to send a document at once, so it will divide the data into segments and then send it one by one. Every time when a segment is transmitted to another node will provide the acknowledgement that it has received the segment. Then the first node will send the another segment with the higher number. Network layer then route the packet to destination by selecting the best path. Data link layer will process the frames. It is mainly responsible for identifying the device uniquely in local network. Data link layer is further divided into two layers: logical link control layer and media access control layer. Physical layer is responsible for transmit the bits from a node to node. It is a lower layer. Similarly, a process starts from lower layer to higher layer. At physical layer, it will receive the data in bits. At data link layer, frames are processed and checked for errors. Network layer will handle the packets. In transport layer, TCP connection will handle the segment, sequence, and acknowledgement. Session will check for synchronization so that synchronization can occur. Data will be decrypted and decompressed at a presentation layer. Means encrypted document and compressed document will be decompressed and de-encrypted here again, so that finally data is retrieved at application layer and can be accessed to view. That's all for the day. Thank you for watching the video.